Okay, cool. Now that we've discussed current and charge, we can now look at a few example questions. The total charge entering terminal is given by Q equals 5t sine 4 pi t millicoulombs. 4 pi t, which is given in millicoulombs. So now we have to calculate the currents at half a second. So from what we've learned before, we know that I is simply dq over dt. Another way to look at this is simply, another way to look at this is simply the derivative of q. And we know that q is 5t sine 4 pi t, and using our product rule, we find that we get 5 sine 4 pi t plus 5t multiplied by 4 pi cos 4 pi t. And once we simplify this, well, not really much simplifying, but we get, that should not be there, plus 20 pi t cos 4 pi t at half a second. We get 5 sine 2 pi, which is simply 0, plus, I think I should make this pen a little thicker so it's better to see. We get half of 20 pi, which is 10 pi, multiplied by cos 4 pi, which becomes 2 pi, since t is half, cos 2 pi, which simply equals to 10 pi. The unit we are given is millicoulombs for charge, so therefore the current will therefore also be milliamps. And to make this into an exact value, or decimal value, we will get something around 3.142 milliamps. And that is how we do question 1. So for question 2, we use the same relationship, but this time we're given the current instead of the charge. So what we have to do here is to make the charge the subject, right? We have to integrate both sides with respect to t. So I with 1 and 2 seconds, right? So it's 2 over 1 over I. In this case, it is 3 t squared minus t dt equals to q. Since we integrate both sides with respect to time, right? And what we get is dq, which we integrate, which gets dt. Okay, so what we get is simply t3 minus t squared over 2, 1. And once we substitute these values into the equation that we just got, what we get is simply 2 to the power of 3, which is 8, minus 4 over 2, since 2 squared is 4, minus 1 cubed is still 1, minus 1 squared, which is still 1, over 2, we get half. And then once we solve for this, we get 6 minus 0.5, and that becomes 5.5. And since we are given amps here, we are going to put coulombs here, since that is the unit of measure for for charge. And now finally we can go on to our third question. The current flowing through an element is this. So we're given a stepwise function here. That means it basically, so what we have here is the formula for the current is different as time goes on. So what we have to do here is apply the same property that we've done before, right? So get the pen tool out again, and what we do is I equals dq dt, right? And we know that we're given I here, so we have to integrate both of these. So to integrate, since we're also given the conditions here, right? So initial condition for the first one is 0 and 1, and this is 4, right? And we differentiate this with respect to time. So we get dt plus 4t squared dt, and the conditions here is actually from, okay, the question here is, I believe, is to find the current flowing from t, right, from t0 to t2. So t0, oops, there is no equal sign, to 2. That is what we have to find. So in order to do that, we have to integrate both of this. The first one is very simple. It's simply 4t 10 plus 4 over 3 t squared, t cubed. And then this is 1 and 2, so this is 2 and 1. And moving down, we get simply 0 to 4, so 4 zeros is still 0, so this simply becomes 4 plus what we get here. We substitute 2 into this equation right here, and what we get is 8 times 4 over 3, which is 32 over 3, minus 4 over 3. And we get 4 plus 28 over 3. We put this in the calculator, and what we get is 40 over 3, which is also 13.3 repeater. And that is the amount of amount of charge flowing past that point from 0 to 2 seconds. And so this should be in coulombs. Hope to see you guys in the next video, and yeah, until next time.